In the previous video, I introduced you to the idea of the four modes or representations of physics, and how to communicate in physics in different ways we try and get the material across or look at situations. And we started talking about people sometimes have different strengths and different ones, but you want to be familiar with all four, be able to use all four to different extents, and different ones have advantages in certain circumstances compared to the others. But we're going to expand on a couple things with each one of them a little bit today. Now, the first one we're going to expand on is that whole physical conceptual one. So, the good old physical conceptual, that right there. And with the whole physical conceptual one, this, of course, is when you observe something or you see something or, you're wondering about something. Now, one of the biggest things about this is you want to try and be critical sometimes. Not always, but often you want to try and be critical. You want to ask questions. A lot of the times you don't just want to take things the way that they are and just assume it's just the way it is, blah, blah, blah. You want to be critical. You want to ask questions. You want to be skeptical sometimes about what's going on. Because doing this type of stuff actually is this is what actually drives better science. It's not about trying to prove yourself right. It's often about trying to prove yourself wrong or prove the situation wrong. And you want to have doubts. You want to be skeptical. You want to ask questions. So don't just take a situation or whatever it is the way it just appears to be. You often want to ask a little bit deeper what's going on, if it's really just the way it is or not. Now, sometimes it is. Sometimes it's pretty simple. It's straightforward, no big deal. But you often want to be critical. This is one of the things that Einstein actually had problems with when he was younger, when he was a student in university. He actually ticked off a lot of professors because he would ask questions. And that was back in the day where you just sort of sat in class and listened and just tried to suck up as much information as that they actually were dishing out. But he had no problem challenging ideas and questioning theories and that type of stuff. And he really ticked off a lot of his professors, and a lot of them got actually really mad at him on a regular basis because of this. But this is exactly what you want to try and do. Not necessarily, tick off your teacher, but you want to try and ask questions, be critical, and, hey, try and take different perspectives and different things like that. So sometimes it's pretty straightforward, but it's sort of what drives the curiosity, which results in better science in terms of what we're doing. Okay? Now, I also want to look a little bit also at the numerical thing a little bit, the whole numerical thing. Now, let's see. All right, the numerical thing. Now, numbers, of course, are numbers and that type of stuff, but there is a whole lot of stuff that kicks in with measurement. Now, for any kind of measurement, there's actually two parts to measurements, and you guys have done this type of thing before, I'm sure. But there's sort of like two main parts to any given measurement. Of course, there's the number part, and there's also the unit part. And of course, number, of course, this is how much there is, whatever it is. This is like the quantity of it, where the unit is more like the quality of it. Sort of like there's quantitative and there's a qualitative part to it. So we've got two parts to it. Now, for the measurement part, in terms of get rid of that. There you go. The how much is whatever. I mean, you guys have looked at numbers before. But in terms of units are actually really, really, really important. Units actually help to actually classify the actual measurement itself. It's not just how much there is. You want that unit to actually help classify it and describe it, categorize it, and there's so many different units. Now, for us, what we do, we actually use part of the SI system. I'm sure you guys are familiar with the SI system. You guys have used it for years. What we actually do is we typically use a subsystem of the standard international system of units. And of course, remember the SI system or the standard international system units, there's 7 main units. We actually use a subsystem. We actually use what is called the Mks Subsystem. And the SI system actually has 7 main units, and the subsystem actually has 5. Now, of course, there's way more than 7 or 5 units, and all the units typically are often combinations of them put in different ways. And we'll sort of show you how that works. So we look at the main units that we've got for what we do, and actually the MKS actually kicks in because those are actually the first letters of 3 of the measurements. For example, the M stands for meters, or the meter, and of course that is our main unit for distance. Now of course there's also centimeters and millimeters and kilometers, but those are all based on the meter with a prefix on them. Okay, and we've also got the K, which actually stands for kilograms, and this is our unit for mass. So this is one of the biggest distinctions between SI and the MKS. Like in SI system, the standard unit for mass is grams, which is typically used in chemistry. We use kilograms. A lot of the stuff we deal with in everyday life is a gram is just way too small, so we just jump right to the kilogram. So that's what we use for mass, and that's where the K kicks in. Now the S is for seconds, which of course is the main unit for time. And that's where you get your M, your K, and your S from. So that's where the MKS system kicks in. Now there's 2 other units which are typically used. And this one's actually from grade 9 science and electricity section. We have the Coulomb. And the Coulomb is used to measure electric charge. Like positive and negative charge of things like protons, electrons, subatomic charges, nuclei, and stuff like that. And the last main unit that we have for this, of course, is the joules. And the joule is the unit used to quantify energy. And Coulomb and Joule are capitalized because they're named after people, and that's the big distinction between capital letters and lowercase letters for units. So Coulomb and Joule are named after people, and the other 3 are not, and that's why they're capitalized. So these are the 5 main units that we have in the MKS system. Now, like we said before, there's lots and lots and lots of other units out there, but they're actually combinations of these. So, for example, you guys in grade 10 science, you took force, and of course the unit for force is newtons. And of course we use lots of forces for stuff, but there's no newtons in this list. Well, that's because if you actually break down like the core part of what a newton is actually made of, a newton is actually a kilogram meter per second squared, which then uses the kilogram meter per second squared, actually uses those 5 units. We can also use it in different combinations, like for example speed. You guys deal with speed in grade 10 when you guys do some kinematics and stuff like that. Of course, speed is in meters per second, so you got the meters and you got the seconds again. And you can do this with pretty much every unit there is. You can actually break it down and pull it back into these 5 main things. Like even when you guys do circuits in grade 9, you've got the ampere, or the amp for current. Well, that's a coulomb per second is what that actually is. That's a coulomb divided by seconds. So this is where units really kick in, help to classify units. But one of the cool things you can actually do with units as well is they can actually tell you where values come from. So for example, if you look at speed, a speed is a meter per second. It actually tells you where the value comes from. Of course, meters is a measurement of distance, and it's divided by seconds, which is measures time. So it's distance divided by time. So it actually tells you where the actual measurement comes from. So units don't just help to classify the different types of measurements, but also one of the cool things about them is they can actually tell you what was actually used to make the measurement in the first place. So to get the unit for speed, you need meters and seconds. You need distance and time. So distance and time are what are used in order to actually make it. Same thing for force. Force is a measurement that involves mass or kilograms, distance in meters, as well as time in the seconds. And those things come together to make that unit. So it's kind of neat how when you start doing more unit analysis later on, you can actually see where a lot of these things really kick in. Okay, so again, a lot of people like to focus mostly on the numbers, but the units can actually become really, really, really important, especially later on as you do more advanced like science and engineering, that kind of stuff. But it's really neat what you can do with them sometimes and sort of extract what's actually things are actually made of, and you can do other things with them as well. Okay, so that is a little bit more about measurement and the measurement system that we like to typically use. But now we're going to look at another little aspect of numbers as well. We've sort of been focusing on the unit part. So now let's look at the number part a little bit as well. But we're going to have to clean this up a little bit. So another really important aspect of numbers, aside from the unit stuff that we're looking a little bit, and if we look at the values, the numerical part, there's another thing that actually really kicks in. And this is where you start talking about significant figures and rounding. And I believe in grade 10 science, you guys do a bunch of stuff with significant figures and rounding and that type of stuff. Basically, when you're using numbers in calculations and science, taking measurements, you basically just can't use whatever you want. You can't just use whatever values you want. You can't just use as many digits your calculator shows as you want. It just shows a lot of inaccuracy and being accurate to places that you are not accurate to. Okay, so I mean, we'll sort of look at this a little bit. So, for example, suppose you have something, maybe got the orange going on. So here's a pumpkin. So I'm going to draw a little pumpkin here. There's a little stem on there. There's a little pumpkin. All right. So then you grab your little ruler or your meter stick, probably if it's a pumpkin, and you're going to measure how wide it is. Well, when you measure how wide it is, you can estimate a little bit, but you can't, have something like, say your watermelon or your pumpkin is 38.125,604 centimeters wide. Okay, that's ridiculous. There's no way you could use a ruler in order to measure the width of a pumpkin to that accuracy. It's just not going to happen. And this is where sig figs and rounding really, really kick in. When you take measurements, you use measurements. You can't just use whatever you want. Okay? When you actually are going to measure something, the amount of values that you can actually use depends on a few things. It depends on the tool that you're using. Some tools are way more accurate than others. If you're using some kind of bendy ruler, it's not going to be nearly as accurate as a nice metal one from like the drafting room or something like that. Okay, so the amount of values depends on things like the tool. It depends on things like the situation. Some things are way easier to measure the length of than others. Some things are curved. Some things are moving. If it's, measure how long a dog is and it's wiggling around. Like, it depends on the tool. It depends on the situation. So you can't just give so many decimals. That's just absolutely ridiculous. Like maybe 38.1 might be okay. Even just 38, those two would probably be okay. But you can't just do whatever you want. Now, the same thing kicks in when you do calculations. When you do calculations, and you're calculating stuff with numbers, and suppose you calculate something like 735.014, blah, 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 and your calculator keeps going. You can't just put all the values you want, because then you're implying that you're actually accurate to that many decimal places or that many places in your value. You have too many significant figures. So when you are calculating stuff, just like when you're measuring stuff, you got to take a little bit of reality and common sense into play and not use every single digit that your calculator gives you. It's not going to work out. Now, there are rules and there are different things that are used for adding, subtracting numbers and multiplying, dividing numbers with things like calculations, that type of stuff. But a general rule of thumb I like to use is when you guys have an answer of some kind, have 2 or 3 significant figures in your answer, and you'll be okay. Okay, even if you use all the rules, you'll probably end up around here somewhere. So, for example, 30. Just using the number from up here, 38.125. That's 5 significant figures. That's too many. 38.13. That's okay. It's pushing it a little bit. Preferably not. But like 38.1. That's good. Even 38, that'd be good. 40, not so much. Now again, there are fancy rules for this type of thing as well, but when you guys are giving answers or calculating stuff, you want to be able to round off your significant figures to show that there's things like error in your answers, and give yourself a little bit of give in that type of stuff in your values, that you don't have unbelievable accuracy that's totally unrealistic. Okay, so if you have 2 or 3 significant figures in your answer, you're probably going to be fine. Now, the other part that kicks in is when you're doing multiple calculations, you calculate something. If you want to keep a couple extra decimals or significant figures through your calculations, that's fine. A lot of people do that. I do that. But then when you get to your end, you want to have 2 or 3 sim configures at the end, and you should be good. Okay, so there's a little bit more about the numbers that we'll be using in addition to what the units we talked about before.